Yeah. So in the last class, we have set up the lab environment. There we created a project, eShop on Web, and that project is a Scrum project, and it is a private project. We selected Git as a source control for that. And then later on, we were moving on in the next lab, we moved on to the board side. So in the boards, we have created new items like we created an epic. Then inside the epic, we created a feature. Inside the feature, we created task. We have seen all the functionalities of work items, boards, backlogs, sprints. Okay. And later on, I think we were on this step, around this step. Created this. We go to the backlogs. I think we created that. We worked on capacity and all. Okay. We have set this capacity and all. Okay.
Yeah, scroll down still.
Hmm.
Still.
Without the dashboard.
No, task 5, from task 5 we need to continue.
Okay. Here.
No, sir, still down. Still. Still. Still.
Okay.
Little more.
Yeah.
And then we get stuff from there. I think now we start to do the dashboards.
Okay. We created this QA approved done. This step till done. I think we have to
Yeah.
start here. Yeah.
Yeah.
Okay.
Unless we did.
Okay. We have to see the configuration wheel settings on the boards panel. Okay. So on the boards panel, we have configuration wheel settings. Here we were about to see swim lanes, I think, or we created that also, expedite.
Yes, we did that.
Okay.
From here, task 5 is there, no? Customize team process.
Customized team process. This we need to do. Okay. So customized team process is a process where you will like, as of now, you are seeing here, whatever it is you are seeing here. For example, if I go to some feature or I go to this feature. Now, whatever is you are seeing over here, like there is a description, there is this product training or whatever options you are seeing, these are limited options to you. Like limited means here is a description, here is an acceptance criteria, then discussion. Maybe you want some different thing over here, some more details. So this particular Scrum process is limited. Now, say if you want to add something more to this board or to this work item. So for that purpose, you have to create your own custom process. Okay. And then you can add. For example, we can see how you can create a custom process. So whatever we are following is a built-in Scrum process. Now to make a custom process out of this, you can simply go to the Azure DevOps organization settings. So you can go to the settings here, go to Azure DevOps organization, go to settings. Here, go to project. Yeah. Go to project, go to process, sorry, go to process on the board side. And here you can see, like we are using, as of now, we are using built-in Scrum process. Now, if I want to move or if I want to create some Scrum process, what I can do? I can click on this Scrum, I can click on this and I can create an inherited process. Means which everything will be inherited by Scrum, but something what we want, we can add it for us in this Scrum process to make it customized. Okay. So let's see. In the organization setting vertical menu in the board section, select process On all process pane to the right of the Scrum entry, select ellipsis symbol and drop down select create inherited process. In the create inherited process Scrum panel, in the process name required text box, type customize Scrum and click create process. Back on the all process pane, click the customize Scrum entry. Now let's see, here you can create an inherited process and give the name of the inherited process, right? So I'll give inherited customized Scrum. Okay. And you can create that particular process.
Mhm.
This is the one, inherited customized Scrum. Okay. Now you can go to that back on the all process pane, click the customize Scrum entry. So back on the all processes, click the inherited customized Scrum, click on the backlog item. Now here you can see what are the backlog items. You can see description. You can see acceptance criteria. That was I was telling that there you are seeing two items only.
Mhm.
But if you want to add some new, you can definitely add new field. Okay, can create a new field. Now you can give the name of the new field. So all processes customize Scrum, select product backlog item. On the all process customize Scrum backlog item, click new field. On the add a field to the product backlog item, on the definition tab, create a field in the name text box, write eShop ticket ID. So this is a new field which we want to give over there. Okay, eShop ticket ID. This is the one.
Mhm.
On the add to field to the product panel, click layout, go to the layout. In the layout, label will be ticket ID over there. Okay, layout. On the add to the product backlog item panel, on the layout tab in the text box, type ticket ID, select the new group option, create a new group option in the group text box, type eShop on web and click add field. Now here in the label, we will give ticket ID, create new group option, and we'll select this eShop on web and we'll add the field. Is the definition eShop ticket ID. Okay, it's already taken. So we'll say write this. You can see a new field is created that is called ticket ID.
Is this global? This ticket ID name should be globally unique.
Like see, in your Scrum process, if you have taken, it's up to your Scrum process. If you have taken that name earlier in your processes, then you have to take a new name. But it's not like that. See, many people have been followed this you can say lab. So they were
Okay.
doing like this only. So it's not like that it's it should be a unique name. Okay.
Okay.
Yeah. It is limited to your process. Okay.
Okay.
Outside the process, it will not be unique. Okay. On the all process, select the Scrum entry on the process Scrum page projects tab. In the list of the projects in the row containing eShop on web entry, select the ellipsis symbol and then click the change process. Now let's go back to the all processes. Here there is a Scrum process. Go to projects. There's eShop on web. There should be work item type. Okay. Not working on the project one. There's one step missing. Xbox eShop and ticket ID on the add field. Click layout. On the add field, layout label text box, create a group eShop on web and add field. Okay. Return to all processes route using the breadcrumb path at the top of all process customize Scrum backlog item. On the all process pane, select the Scrum entry. On the All Process Scrum pane, select the Projects tab. In the list of the project, in the row containing the eShop web entry, select the ellipsis symbol and then the change process. On the change the project process pane, in the select target dropdown, select customize Scrum process, click save. Actually, I have created so many Scrum process over there, 3 or 4, I think. Mm, but it is showing only 3 for demo project. Okay. All processes. So 1, 2, 3, 4. Set as a default process. Okay. No, not default. Go to Scrum process. Now here it should show like this change process. It's showing eShop on web 1. Mm, no worries, I'll show you in this project. Target process.
Inherited customized Scrum, that's the one you had.
The change process pane, select the target process or select the customized Scrum process. Click save and close. Let me delete others. Okay. Mhm. Let me disable this one too. Let me delete this one as well. Okay. Huh. Okay. Now let me create another one here. Let's go create inherited process. So now I'll create customized Scrum. Again, I'll create the process. I'll go inside the customized Scrum. I'll go in the product backlog item, create a new field, create a field. I'll give the name as uh, eShop on web ticket ID. Give this. Okay. Go to options, eShop on web ticket ID. I'll take the ticket ID from here and I'll create a new group that will be eShop on web. Hmm. Ticket ID is created now. Return to all processes route using the breadcrumb path. All process customize Scrum product backlog pane. All processes select the Scrum entry. Let's go to all processes now. Select the Scrum entry. Scrum entry. In the Scrum entry, Scrum pane, select the projects tab. In the list of projects in the row containing the eShop web entry, select the ellipsis symbol and then select the change process. Hmm.
Middle one, sir. Middle one.
A middle
Yeah.
one is another. Actually, this is I created eShop on web for you guys and eShop on web one for the other class. It is showing that one.
Try refresh page.
If I'll change this to my new customize or customize Scrum, then that will be okay. First let's move this one to change process. Okay. I can click on here, go on projects. Oops. So as of now, it is not showing, but if you go on yesterday, not yesterday, on Saturday, I demonstrated that to them. If you go to the board's product training, now here also it has changed. Here it is showing eShop on web one, shop on web. Here it is showing in the My Customized Scrum. Now you may see that. Now you can see in the Scrum you have eShop on web. Okay. You can click, you can go to the change process and you can change it to your customized one, which you have opted to the customized Scrum. Once you change that, close it. Click on Azure DevOps logo, return to the root page. On the project, select the entry representing eShop on web. In the eShop on web, select boards and ensure the work item pane is displayed. In the list of work items, click the first backlog item. Okay. Let's go to the projects over here, eShop on web, boards, backlog. Can you see this? We have customized this. Okay, now this has been moved to the customized Scrum process. Since we have added one more field over here, that is ticket ID. Now you can give any ticket ID over here like this. Okay, so as per the ticket ID, you can track your tickets. Like you have ticket ID in Jira and other boards like ServiceNow and all. Okay, so you can add a ticket ID over here. So whenever someone will create a new ticket, then you will be having a ticket ID as well. For now, when we were doing this, we were not having any ticket ID. So that
Okay,
will
sir.
be
Uh,
that will,
there is already one ticket ID, I think, 404 or something. Right. Could you go back, sir, please?
Mhm.
Uh, just click on that here on at the top, product backlog item 404.
Mhm. No, this is work item number. This is not
Okay,
ticket ID. Okay, work item number is different, ticket ID is different.
okay, sir.
Okay. Ticket ID will be some 6 to 7 digit number. Okay.
Okay, sir.
Yeah. Okay, this is done. Scrum process. Now define the dashboard. Now, what we'll do, we'll see the dashboard. In the vertical navigational pane of the Azure DevOps portal, select the overview icon and in the list of the overview items, select dashboards. In the necessary, on the dashboards pane in the upper left corner in the eShop on web team, select eShop on web team overview. Oh, let's see where's the dashboard. Let's go to the overview panel. You, you can go to the dashboards. So in the dashboards, here you can see in the drop down, eShop on web and eShop on web team. Okay. So if you click on here, team overview, there is a blank dashboard over here. You can see that. Okay. Team overview, review the existing dashboard. On the dashboard pane, select the drop-down menu. Next, eShop on web team overview and select the new dashboard. So here, as of now, we don't have any widget. Okay. So already this has been created, team overview. Will not create any new dashboard over here. If you create any new dashboard, you can give the name of the dashboard and you can create a new dashboard. Already, I think on that day we have created this. Maybe we have not filled that new dashboard. Okay. On the create dashboard in the name text box, product training in the team drop down. Okay. So name of the new dashboard will be this one. Select the eShop web team and click create. So here you will go to create a new dashboard. Name it product training eShop on web team. eShop web team. Okay. Select this. Create that dashboard. Now product training dashboard is created. Now you will be adding the widget. So what you will do? On the new dashboard, click add a widget. On the widget, search text box, type sprint. Now let's add a widget in this product training dashboard. So searching for the sprint over here. So that two. One is
Overview.
sprint capacity, sprint overview. Okay. So if you, what is the first they are and sprint
Overview.
Oh, yeah. Go to overview, click on add. Now you can see the sprint overview over here.
Mhm.
In the rectangle representing the newly added widget, click the settings configuration wheel icon and review the configurations pane. So here you can click on this wheel and you can review that. Team is this one, values, what are the values? Show non-working days, you can choose that. Okay. And then what else? Another widget on the configuration pane, click close, make without making any changes, back onto the add widget pane in the search text box, type sprint again. Now here we'll add the sprint capacity now. So if you type the sprint over here, sprint capacity. Okay. Now here maybe there is no capacity added. You have to set the capacity first. In the dashboard view at the top, click done editing. In the vertical navigational pane of the Azure DevOps portal, select the boards icon and list of the boards items, select queries. Uh, Now you can see the sprint. Now let's go to the boards and queries. Let's see how to create queries. You can create a new query over here. Work item in the new query, you can take like work item type equals to what is the work item type here.
Task.
Yeah. Okay. Work item type, select task. Select task and then state area path. So area path equals to whatever is the area path you are having. Now area path value this one, eShop on web and eShop web.
Area path.
Like this. Click Save Query. In the new query panel in the Enter Name type box, click Web Task. In the folder drop down, selected queries. Now, if you're saving a query here, save query, enter the name of the query as Web Task, and instead of My Queries, because if you save in My Queries, it will show to you only. But if you do in shared queries, okay, I'll do this one now. On the configuration chart panel in the name text box, web task by assignment. Select the charts tab and click new chart. Okay, charts tab, click on new chart. Here you can give some name to that particular chart. So let's take this one. Group by assigned to. Okay. And then you can click on OK. And what you can do, this query you can also add to your dashboard. Add to the dashboard. Which dashboard? The product training dashboard which you created. Okay. How many dashboards? 3 times I created that same dashboard over there. Okay. So if you go to the dashboards now, here if you will see the product training, you can see that is added over here. So this is how you can maintain the boards. Okay. Now this second lab is done. Let's go to the third one. Here we will be seeing all the things about the version control. Now version controlling with Git repos. Okay. There's a new thing over here. Earlier when I was demonstrating, we have seen version control from the local. Okay, starting from the local, how to create a project in the local, how to move that project into the version control, and then how to manage that. Maybe here they are demonstrating it with Visual Studio also. Okay. So lab overview, Azure DevOps supports two types of version control, Git and Team Foundation version control. Here is a quick overview of the two version control systems, Team Foundation version control and Git. Okay. Now, I've also included one chart. Maybe sometimes you guys can have confusion. So I've included that one chart into the recordings from Wednesday. So this chart is about comparison. Okay. Comparison between Azure DevOps tools and the enterprise tools. Sometimes you may have confusion, like in the enterprise type, in the version controls system, we have Git. Central repo for Git is GitHub. Now here in the Azure DevOps, the counterpart of that central repo is Azure DevOps. Now it follows centralized also, distributed also. Centralized version control as well as distributed. For centralized, we have TFVC, Team Foundation Version Control, which is an implementation of TFS. And for distributed, we have Git, that is implementation of GitHub. So whatever the Git commands you will be running here, same Git commands you will be running here. The difference is you will be pushing here to the GitHub. Here you will be pushing it to the Azure repos. That's it. Then continuous integration and deployment. Here, enterprise tools, most popular one, Jenkins. Here, build and release pipelines. Then microservice deployments. Here it is Docker container. Here it is container apps. Here central repo for Docker is Docker Hub. Here central repo for container app is Azure Container Registry, ACR. Here container orchestration tool is Kubernetes. Here container orchestration tool is AKS, Azure Kubernetes Service. Monitoring, here you can have app monitoring. You can have different monitoring softwares, but the most popular one is Prometheus and Grafana. Okay. In the log monitoring, you have EFK, Elastic Filebeat, Kibana. Okay. Kibana is the dashboard over here in the log monitoring. Grafana is in the application monitoring. Here we have application monitoring as Azure Application Insight, log monitoring as Azure Log Insight, and dashboard for displaying all those things. We have Azure Monitor over here. Configuration management tool, Ansible, most popular one, enterprise tools. Here we have ARM templates. Okay. Some other tools for infrastructure provisioning like Terraform, that is also enterprise tool. Here there is no different tool, but you can use Terraform here as well with Azure DevOps. You can provision your infrastructure using Terraform in Azure DevOps as well. Okay. So that is the difference between tools at different stages between Azure DevOps and an enterprise DevOps. Okay. So lab overview, Azure DevOps supports two types of version control, Git and Team Foundation. Team Foundation means is a centralized type of version control. We already discussed. Git is distributed one. Now objectives, clone an existing repository, save work items with commits, review history of changes, work with branches by using Visual Studio Code. Now configure the lab here. In this exercise, you will set up the prerequisites of the lab, which consist of a new Azure DevOps project with the repository. So now create a project, skip if it is done. We already done it, so we'll skip it. Import eShop on web Git repository, skip if done, so we'll skip it. Okay. In this task, since this is done from the first lab only. Okay. In this task, you will import the eShop on web Git repository that will be used by the several labs. On your lab computer in a browser window, open your Azure DevOps organization and previously created eShop on web project. Click repos files import. On the import a Git repository window, paste the URL. So This all we followed. This all we followed from the first lab itself. Okay. So till here you don't have to do. Now configure Git and Visual Studio. In this task, you will install and configure Git and Visual Studio code, including configuring the Git credential helper to securely store the Git. Credentials used to communicate with Azure DevOps. If you have already implemented these prerequisites, you can proceed directly to the next task. Now here on the lab computer, open your Visual Studio Code. In the Visual Studio Code interface, from the main menu, select Terminal, New Terminal to open the terminal pane. You can go here, you can open your Visual Studio. Visual Studio Code. Okay, they're asking to go for the code. So this is our Visual Studio Code. Okay. Now what they are saying. In the Visual Studio Code interface, from the main menu, select Terminal, New Terminal, open the terminal pane. Okay. Now go to the terminal, click on New Terminal. Now here is our terminal. Make sure that the current terminal is running PowerShell by checking if the drop-down list at the top right corner of the terminal pane shows PowerShell. Okay. It shows PowerShell. Okay. In the terminal pane, run the following command below to configure the credential helper. Okay. Now let's see. Now first I'll change this path to our project like Azure DevOps. Okay. I'll change it to here. Create a new folder over here. eShop. I'll go inside eShop. I'll go to CD. Now I'm on the eShop. Now let's see. Git config -- global credential dot helper win credentials. Okay. So let's go here. We already have this, I think. Now we'll run this. Let's take our username from here. My username. This is my username. I'll configure the email. Copy it again. I'll do one thing. This is okay. Clone an existing repository. In this exercise, you use Visual Studio to clone the Git repository you provisioned as part of the exercise. Clone an existing repository. In this task, you will step through the process of cloning a Git repository by using Visual Studio. Switch to the web browser displaying you the Azure DevOps organization with the eShop on web project you generated in the previous exercise. In the vertical navigation pane of the Azure DevOps portal, select the repos icon. In the upper right corner of the eShop on web repository pane, click clone. So here, if you will go to eShop on web, click on the repos. In the repos side, you will find the repository at the top. Okay. So this is the repository, eShop on web. Okay, this is the repository. You can click on clone, right hand side. So now in the upper right corner, eShop on web, click clone. On the clone repository panel with the HTTPS command line option, click the copy to clipboard button next to the repo clone URL. Clone the clone repository URL panel. Switch to Visual Studio Code running on your lab computer. Click the view menu bar header. In the drop down menu, click command palette. At the command palette prompt, run the git clone command. Okay. So let's clone this one. Let's take this HTTP URL, click copy to the clipboard. Go to your Visual Studio. On the views section, command palette you are seeing. Now in the command palette, if you type git clone, so you will find git clone. Okay. Click on that. Provide the URL. This is the URL. Okay. This is the URL. Now this will open where you want to clone it. Okay. So you can select the folder name. In the provide repository URL or pick a repository source text box, paste the repo clone URL you copied earlier task and press the enter key. Within the select folder dialog, select the C drive, create a new folder named Git, select it and then click select repository location. Okay. When prompted, log into your Azure DevOps account. After the cloning process completes, once prompted in the Visual Studio Code, click open to open the clone repository. Let's select it has opened that clone repository. Okay. So all the files which you cloned, you are seeing it here now. Save work with commits. Now we'll see. In this exercise, you will step through several scenarios that involve the use of Visual Studio Code to stage and commit changes. Let it be. So when you make changes to your files, Git will record the changes in the local repository. You can select the changes that you want to commit by staging them. Commits are always made against your local Git repository, so you don't have to worry about the commit being perfect or ready to share with others. You can make more commits as you continue to work and push the changes to others when they are ready to be shared. Git commits consist of the following: the file or the files change in the commit. Git keeps the contents of all file changes in the repo in the commit. This keeps it fast and allows intelligent merging. A reference to the parent commit. Git merges your code history using these references. A message describing a commit. You give this message to Git. These are things which we are talking about. We are giving on the Git while committing, while adding all those things. Okay. So you give the message to Git when you create this commit. It's a good idea to keep this message descriptive but to the point. Commit changes. In this task, you will use Visual Studio to commit the changes. In the Visual Studio Code window at the top of the vertical toolbar, select the Explorer tab, navigate to the program.cs file and select it. This will automatically display its content in the pane. Okay, so let's go to the Explorer with that Explorer tab. Okay, this is our Explorer tab. Let's close this one, this one. Okay, so this is our Explorer tab. Let's go to program.cs. Inside the project, it will be. eShop on web, source, web. App settings is there, content cs, program.cs is the file. On the first line, add the following comment. Let's copy this comment over here. It doesn't really matter what the comment is since the goal is just to make a change. Press Ctrl plus S to save the change in the Visual Studio Codes window. Select the source control tab to verify that Git recognized the latest change to file residing in the local clone of the Git repository. Okay. So let's add that. Let's add that comment at the top here. My first change. What I'll do, I'll click on Ctrl S. That will be saving my file here. Select the source control tab. Select the source control tab to verify that the Git recognized the latest change to the file residing in the local clone of the Git repository. With the source control tab selected at the top of the pane in the text box, type my commit as the commit message and press Ctrl plus Enter to commit it locally. So here you can give the message. What message? My and commit. Control plus enter. There are no stage commit. Would you like to stage all your changes and commit them directly? Okay. So this will commit in your local. Now my code has been committed. It is asking to sync the changes. Means syncing means if I click on sync, it will push it to the main repository. As of now, I did the change in my local only. If you go to the repository over here, you will not find any changes in the file. If you go to the source, inside the source, you will go to the web. Inside the web, you go to program CS. As of now, you will find no change. Nothing as added be over there. But if I click on this sync changes, it will push it to a remote repository. Okay. So change with the source control tab selected at the top of the pane in the text box, type my commit. This is done. If prompted whether you would like to automatically stage changes and commit them directly, click always. Okay. In the lower left corner of the Visual Studio Code window to the right of the main label. So lower left corner where it is, this is the lower left corner. Okay. And this is a main. This is a main. Note the synchronized changes icon of a circle with two identical arrows, two vertical arrows, sorry, two vertical arrows pointing in the opposite directions, and the number 1 next to the arrow pointing up. Let's see that. See, there is one here, there is an arrow pointing upwards, and there is a circle also. Okay. Next to the arrow pointing up. Click the icon and if prompted whether to proceed, click OK to push and pull commits to and from the origin main. Okay. Review commits. In this task, you will see the Azure DevOps portal to review commits. Switch to the web browser displaying window, Azure DevOps interface. In the vertical navigational pane of the DevOps portal in the repos section, select commits. So if you click over here, this section will pull and push commits from and to the origin main. Now it is syncing the changes over here. So you can directly click over here also and here also, whatever you want. Now you can go here and go to commit section. Can you see this my commit now? Yes, we have done this commit from our local and push it to our remote repo, my commit. If you go to the repos and if you go to program.cs inside the source, web and program.cs, you will see my first change. So it is pretty much easy to work in with Visual Studio Code or Visual Studio 22. Okay. Visual Studio 22 is more enhanced. Okay. Visual Studio Code you can just use for simple changes, simple Git changes, editing a file, pushing a file, pulling a file, fetching it, all those things you can use with Visual Studio Code. Okay. So we have reviewed that commit, verify your commit appears at the top of the list. Stage changes. In this task, you will explore the use of the staging changes by using Visual Studio Code. Staging changes allows you to selectively add certain files to the commit while passing over the changes made in other files. Now switch back to the Visual Studio Code window. Update the program.cs class by changing the first comment with the following and saving. Now update the open program says by changing the first comment with the following. Now that first comment will change with the following here. So let's go to this file only. Change will change with the second one, my second. Okay, press up Control S over here now. In the Visual Studio Code window, switch back to the Explorer tab, navigate to eShopware constant.cs file and select it. This will automatically display its content and details. Add the constant.cs file a comment on the first line and save this file. Okay, we'll copy this and we'll go to the file again. Now we'll click on the Explorer tab. We'll go to the constant.cs file. Here at the top, we'll add this, my third change. Okay. And save the file. Now we'll be saving the file here as well. You have saved this one as well. In the Visual Studio Code window, switch to the Source Control tab. Hover the mouse pointer over the program.cs entry and click the plus sign on the right side of that entry. Let's see. So go to the program.cs. First go to your source control, then program.cs, then there's a plus sign, state changes. Okay. Over the program.cs entry and click the plus sign on the right hand side of that entry. With the source control tab selected at the top of the pane, in the text box, type edit comments as the commit message. So here we'll click and what we'll do on the program CS side. Edit comments. At the top of the source control tab, click the ellipsis symbol in the drop down menu. Select commit and in the cascading menu, select commit staged. So again, what we'll do here, commit. There's one more option over here in the ellipsis button. Commit staged. Okay. In the lower left corner of the Visual Studio Code, click the Synchronize Changes button to synchronize the commit changes with the server. And if prompted whether to proceed, click OK to push and pull commits over the origin. Review the history. Okay, let's go back again. Now this is working on that particular. Review history. In this exercise, you will use the Azure DevOps portal to review the history. Git uses the parent reference information stored in each commit to manage a full history of your development. You can easily review this commit history to find out when file changes were made and determine the difference between versions of your code using the terminal or from one of the many visual. Now, it is showing that whenever you are working on your local Git, it like if you don't have to push it that particular time, means you are working in one file, you have saved the changes. If you are working on another file, you are making changes in that file also. So what you can do, you can stage your commit. You can stage your commit. Means you can keep it once done, you can keep it and for further pushing it to the main repository. So always whenever you are working like this, one file, two file, what you will do, you will stage your commit. Okay. Don't commit and push it directly. You can stage your commit, and at the last, what you can do, you can click on that, the button which is shown over here. You can click on that, and at the same time, you can push your all the commits after staging it. Okay. At once. So that's what it was showing over here. Okay. Go to your commits. Now you can see this. After my commit, there we have done two commits. One is edit commit comments, and second one is the commit. So we have done both at once. Like we have edit one file, we have added another file. Then we have committed them both. So what we have done, the staged commit, and then at once we have pushed both the commits. So we have pushed both the commit in that particular case at once only. Okay. Now compare the file. In this task, you will step through commit history by using the Azure DevOps portal. With the source control tab of the Visual Studio Code window button, select constant.cs representing the non-staged version of the file. Okay. Switch to the web browser displaying the commits pane of the Azure DevOps portal to review the source branches and merges. These provide a convenient way to visualize when and how changes were made to the source. Okay. Scroll down to my commit entry pushed before, and however the mouse pointer over it to reveal the ellipsis symbol to the right side. Click the ellipsis in the drop down menu, select browse files and review the result. Now here there is an ellipsis symbol over here. So if you go and browse the files over here, inside this source web, it's not updated yet. That's what comparison they are showing. Means you have staged the commit. Okay. And here the commit which you did directly over, which you pushed over here, and whatever you have staged. Okay. So they are comparing between these two, like first commit and second. History, in history, they will show you like there is a my commit over here, and then the comparison side by side. You can compare your files like you are comparing it over here. Work with branches. Okay, in this exercise, you will step through scenarios that involve branch management by using Visual Studio Code and the Azure DevOps portal. You can manage in your Azure DevOps Git repo from branches view of Azure DevOps in the Azure DevOps portal. You can also customize the view of the track, the branches you care most about, so you can stay on top of the changes made your team. Committing changes to a branch will not affect other branches, and you can share branches with others without having the merge the changes into the main project. You can also create new branches to isolate changes for a feature or a bug fix from your main branch and other work. Since the branches are lightweight, switching between branches is quick and easy. Git does not create multiple copies of your source when working with branches. So Git will not create multiple copies of your code when you are working with the branches. It will do it for only for the production or the default branch, whatever will be the default branch. So always the production will be the default one. Okay. But rather uses the history information stored in the commits to recreate the files on a branch when you start working on it. Your Git workflow should create and use branches for managing features and bug fixes. The rest of the Git workflow, such as sharing code and reviewing code with pull request, all work through branches, isolating work in branches, making it very simple to change what you are working on by simply changing your current branch. Create a new branch in your local repository. In this task, you will create a branch by the Visual Studio Code. Switch to Visual Studio Code running on your lab computer with the source control tab selected in the lower left corner of the Visual Studio Code. Click Main. In the pop-up window, select Create New Branch. Let's go here. First, let's go here. Okay. Then let's go to the source control tab. Source control tab. Lower left corner, click on main and click on create new branch. Create new branch from. In the branch name text box, type dev to specify the new branch and press enter. In the select a reference to create the dev branch from text box, select main as the reference branch. So again, click on this create branch from. Okay. So reference will be main. Please provide a new branch name. So I'll write dev over here. Press enter to confirm. Now a new branch has been created. Now dev branch, text select main as the reference box. Delete a branch. In this task, you will use the Visual Studio Code to work with a branch created in the previous task. Git keeps track of which branch you are working on and make sure that when you check out a branch, your files match the most recent commit on that branch. Branches lets you work with multiple versions of the source code in the same local Git repository at the same time. You can use Visual Studio Code to publish, check out, and delete branches. In the Visual Studio Code window, with the source control tab selected in the lower left corner of the Visual Studio Code window, click Publish Changes icon directly to the right of the dev label representing your newly created branch. Okay. So where is that Publish Changes icon? This is the one.
On top, on top.
On top is there. You will find on top also and here also beside dev. Okay. Like this. Same
So
thing.
either one we can.
You can click over there also. You can click over here also. Okay. Switch to the web browser window displaying the commits pane of the Azure DevOps portal and select branches. Commits pane. branches. On the Mine tab of the branches pane, verify that the list of the branches included dev.
Check what the main is. For mine, yeah.
Can you see dev is included now?
Yeah.
Okay. Hover the mouse pointer over the dev branch entry to reveal the ellipsis symbol on the right side. Click the ellipsis symbol in the pop-up menu, select delete branch, and when prompted for confirmation, click delete. Switch back to the Visual Studio Code window, and with the source control tab selected in the lower left corner of the Visual Studio Code window, click the dev entry. This will display the existing branches in the upper portion of the Visual Studio window. Verify that now there are 2 dev branches listed. Okay. Let's see here. Let's click on that. Delete branch. Delete it. Go to the Visual Studio Code. Click on source control.
Checkout.
No, here. Wait, I'll do this. So dev branch, main branch, origin dev, origin main, like this. Okay. So one branch is this one, and this is in the cloud side. Okay. Can you see this? The local dev branch and the origin dev branch. That's why they are calling 2 dev branches. In the list of the branches, select the main branch to check it out. Press Ctrl Shift P to open the command palette. At the command palette prompt, start typing git delete and select the git delete branch when it comes to visible. Select the dev entry in the list of the branches to delete. Okay. So select the main branch to check it out. Here you will click on that. Select the main branch. Now you're on the main branch and you will open the command palette. So Control Shift P is the button for command palette. And what you will type git delete. Okay. So git delete.
Branch.
I want to delete dev branch. So I'll click on dev now. Okay. So dev will get deleted. Select the dev entry of the list branches. In the lower left corner of the Visual Studio, click the main entry again. This will display the existing branches in the upper portion. Verify that the local dev branches no longer appears in the list, but the remote origin dev is still there. Now, if you will click on the main side, here you will find main and origin main. Okay. Whatever dev was there, it was deleted. Dev entry was deleted. Okay. But the remote origin dev is still there. Press Ctrl Shift P to open the command palette. At the command palette prompt, start typing git fetch and select git fetch prune when it becomes visible. This command will update the origin branches in the local snapshot and delete those that are no longer there. You can check in on exactly what these tasks. This task wants to say that whenever you are deleting some branch from your remote repository, Now your Visual Studio Code is still having the copy of that deleted branch from the origin. Origin means remote. Now you can delete that particular branch from your local, from the Visual Studio Code, but still that origin branch will be visible because it is maintaining a copy of that. This Visual Studio Code is maintaining a copy of that. So what you have to do now, you have to run a command which is called git fetch, and in the bracket you are seeing this prune. You are seeing this prune. You can check in on exactly what these tasks are doing by selecting the output window in the lower right part bottom of the Visual Studio Code window. If you don't see the git logos in the output console, make sure to select git source. Now, what I'll do, I'll give you a handout. In that handout, I'll give all the git commands and their working, what they do. So mostly what they do in interviews, they ask commands sometimes like, what is git prune? Like, what do you mean by git prune? Okay. So just you should remember all these things. I'll give a handout of git commands to you. Okay, I'll update that. So go to the command palette again. Okay. In the lower left corner of the Visual Studio, click the main entry again, verify the original dev branches no longer appears. Now I'll again click on that. I'll go to source control again, and main is selected. Okay. I'll go to the control panel. I'll type git. Can you see git fetch prune now?
Yes, sir.
Now after doing this, what will happen? If you now again click on here in the main branch, okay, now you will not see that origin dev. Now it has deleted that copy of the origin, means remote dev branch, which was maintained by Visual Studio Code. Got it? Yeah. So that's why we are using git prune over here, so that we can delete that copy of the origin dev branch. This is clear, right? Why you used git prune and all.
Yeah.
Okay. See, it's very easy. They have given step by step, and they have wherever it is necessary, they have given the description as well. Okay. So delete branch, we have done this one here. In the lower left, we have checked that no longer, and restore a branch. In this task, you will use the Azure DevOps portal, restore the branch you deleted in the previous task. Go to the web browser displaying the Mind tab of the branches pane in the Azure DevOps portal. On the Mind tab of branches pane, select All tab. In the Mind tab, select All tab over here. On the All tab of the branches pane in the search box, search branch name text box, type dev. Can you see this deleted branches? Review the deleted branches section containing the entry representing the newly deleted branch. In the deleted branches section, hover the mouse pointer over the dev branch entry to reveal the ellipsis symbol on the right side. Click the ellipsis in the pop-up menu and select restore branch. You can use this functionality to restore a deleted branch as long as you know its exact name. Okay. This is the, now you can click on restore branch. So this will restore your branch. Now in the all branches, you can see this dev branch also. Okay, you have restored a branch. Now branch policies. In this task, you will use the Azure DevOps portal to add policies to the main branch and only allow changes using pull requests that comply with the defined ones. Okay. For simplicity, we'll work directly on the web browser repo editor. working directly in Origin instead of using the local clone in VS Code. Switch to the web browser displaying the Mind tab of the branches pane. Okay. On the Mind tab of the branches, hover the mouse pointer over the main branch entry to reveal the ellipsis button on the right side. Click the ellipsis button and pop-up menu. Select branch policies. On the main tab of the repository settings, enable the option of require minimum number of reviewers. Now, here you will see the main branch. Go to the branch policies. Now, first thing in branch policy is require number of reviewers. Add one reviewer and check the box allow requesters to approve their own changes as you are the only user in the project. Now, here I'll give it 1 and allow requesters to approve their own changes. Since I am the whole sole owner of this project, so I'll choose this one. Okay. You can also use prohibit the most recent pusher from approving their own changes. Allow completion even if some reviewers vote to wait or reject when new changes are posted. Okay. On the main tab of the repository settings, enable the option for check for linked work items and leave it with required option. Enable the option for checked for linked work items. Okay. So required. Whatever is there, you can have it default, like block pull request from being completed unless they have at least one linked work item. Testing branch policy. In this task, you will use the Azure DevOps portal to test the policy and create the first pull request. Now here in the vertical navigational pane of the Azure DevOps portal in the repos files, make sure the main branch is selected. Drop down above shown content. To make sure the policies are working, try making a change and committing it on the main branch. Navigate to the program.cs file and select it. This will automatically display its content in the pane. On the first line, add the following comment: testing main branch policy. Click on commit. You will see a warning. Changes to the main branch can only be done using a pull request. Okay. Click on the, now let's see here. These options are enabled. Let's go to the eShop on web. Repos, files, and then again that particular file, source, web, and program.cs. Edit this. Commit. Pushes to this main branch are not permitted. You must use a pull request to update this branch. Okay. So now I have enabled that policy, so I cannot commit anything over here. So it will work on this on your organizations this way. Like you cannot push directly into the main branch. You are protecting your main branch. You are enabling a security feature. Now, how to work with pull request, that is the last step. In this task, you will use the Azure DevOps portal to create a pull request using the dev branch to merge a change into the protected main branch, and Azure DevOps work item will be linked to the changes. In the vertical navigation pane board, select work items. Now we'll see how to do the change with the work items. In this vertical pane on the Azure DevOps portal, in the board section, select work items. Click on the new work item, product backlog item. In the title field, write testing my first pull request. Click on save. Go to the boards. Leave this. Now in the boards, you can click on new work item and can create a product backlog item. Enter the name, testing my first PR, and save it. Now go back to the vertical navigational pane on the Azure DevOps portal, repos file, make sure the dev branch is selected. So go to the program CS file, testing my first PR. Commit it, leave default commit changes. Commit message. This time the commit works. Dev branch have no policies. A message will pop up proposing to create a pull request as the dev branch is now ahead in changes compared to main. Click on create a pull request. In the pull request tab, leave the defaults and click on save. Let's see. So now testing my first PR, save it. Again, go to repos, select files, select dev, go to source, go to web, go to program.cs, and then testing my first PR. Edit, testing my first PR. Commit, whatever is there. Commit it. It will let you commit. Now you can create a pull request here from dev to main. In the pull request tab, leave defaults and click save. The pull request will show some field pending requirements based on the policies applied to our target main branch. Proposed changes should have a work item link. At least one user should review the approve the changes. Now, without giving anything, create the pull request here. One required check failed. Work items must be linked. Okay. Or at least one reviewer must approve. On the right side options, click on plus button next to work items. Link the previously created work item to the pull request by clicking on it. You will see one of the required changes status. Now, where is that plus button? Add, show everything, tags, work items. Now in the work items, testing my first PR. Have to link that. Now the required check has been completed. What else the required check is? At least one reviewer must approve. So as of now, there is no approver. So what you can do? You can provide. Now there is a reviewer. There is a product backlog item as well. Edit. Next, open the files tab to review the proposed changes in a more complete pull request. You would be able to review files one by one marked and open comments for lines that may not be clear. Hovering the mouse over the line number gives you an option to post a comment. Go back to the overview tab and on the top right, click approve. All the requirements will change to green. Now you can click on complete. Click on complete. Okay. So you can move to files here. Updates, commits. Okay. Overview. Everything is complete here. You can see approve. Okay. Now everything is checked over here. You can click on approve.
You have to press complete too.
All the required changes will be green. Now you can click on complete. On the complete pull request tab, multiple options will be given before completing the merge. Merge type, 4 merge types are offered. You can review them here on observing the given animations. Choose merge, no fast forward, post, complete options. Check complete associated work item. Now, if you go here, you can have like complete, mark as a draft, abandon. If you click on approve, wait for author, all these things. Here also. See, now in the merge type, you can have merge, no fast forward. What else you can have over here? Squash, commit, rebase, and fast forward semi-linear merge. Okay. post complete options, check complete associated work item. It will be move associated PBI to done state. Click on complete merge. Apply tags. Now for applying tags. So this is done. You can choose from here. Okay. There is one more item, like you can see over here. What are the other merge options? Like complete a pull request. So in the pull request, you have here merge no fast forward, merge with a non-linear history that preserve all commit, squash commit, merge with a linear history that combines all source commit into a single commit on the target, or squash merge the PR. Be aware that a new commit will be created for the target branch without keeping the commit history from the source branch. Rebase and fast forward. Rebase the source commit into the target and fast forward. Semi-linear merge. Rebase source commit into the target and create a two parent merge. Okay, so these are the options you can get. As of now, we will be doing just no fast forward. So this will be done. So commit is done now. If you go to the files section, in the main, you will find that change, okay, in the source. Web. Inside web, you can go to program.cs. Testing my first PR is done now. Now applying text, this is the last one, just will take 2 minutes. The product team has decided that the current version of the site should released as version 1.1.0-beta. In the vertical navigational pane of the Azure DevOps portal, in the repos section, select tags. Let's go to the and select the tags. Here are tags. In the tags pane, click new tag. In the create a tag panel, in the name text box, click this. Now they have decided that whatever the release will be from this name. Okay. So you are creating a tag for that. In the based on now create a tag panel. First, let's go to the create a tag. Okay. New tag. Name of the tag you can give. Based on drop down main branch selected in the description text box, type beta release this and click create. So main branch is selected, and in description we can write this beta release. Okay. And click create. You have now tagged the repository as this release. The latest commit gets linked to the tag. You could tag commits for a variety of reasons, and Azure DevOps offers the flexibility to edit and delete them, as well as manage their permissions. Okay. So create a tag. So now tag is for, you know that, okay, you got to know that whenever we do some releases and we got some release number or whatever release we want to do, okay, we can create a tag out of the main branch of the production brand, and we can use that particular tag to release some new development feature or anything. Okay. Now in this lab, we have seen the version control, the repositories, the branches, the all of those things, which we have seen while we were seeing the components. So we have seen all things at once while doing this lab. Okay. Now there is a lab 3. Here we will be configuring the agent pool, and then we'll see the pipeline styles. Now here in the pipeline style, we see YAML pipeline also. Earlier we have seen classic editor pipeline. Now we'll be seeing the YAML pipeline as well. So that is it for today. I'll be stopping.